Welcome back to this channel, guys. In this video, we'll be taking a look at compound angles and we'll be limiting our formula to sin A plus B and also cos A plus B. Now, to get sin A minus B and cos A minus B, we'll not be going through this proof anymore. We'll be using what we are getting for the addition to generate the one for subtraction. Also, when it comes to tan A plus B and tan A minus B, we'll be using the relationship between sin, cos, and tan to generate the formula for tan A plus B without going through this geometry. Now, to solve for sin A plus B, we have to take note that what we have here is not drawn to scale, but what we have here is two right angle triangle. There's one above and there's one below. For this right angle triangle, this is angle A, your 90 degrees, your opposite, adjacent, and the longest side of the triangle, which is this hypotenuse. Now, for triangle B, this is opposite, this is adjacent, and this is the hypotenuse. Now, having this in mind, let's move on to this side of the board. So we are going to be generating a formula for getting the side opposite your angle and also a formula for getting the side adjacent to your angle. Now, I'll be using that relationship to generate the formulas, to generate the figures for this particular side of our triangle. Now, if you look at this, remember, this is opposite, this is adjacent, and this is the hypotenuse. And by convention, we are told that at any given point in time, our sin theta is always equal to opposite over hypotenuse. In this case, my theta remains theta, my opposite is y, my hypotenuse, by convention, we're calling it arrow here. So this is simply sin theta is equal to y over arrow. So y is equal to arrow sin theta. So I can put that here, arrow sin theta. Now, for this side, using the same thing, this will be for cos. So we'll be having cos theta is equal to x over arrow. So x is equal to arrow cos theta. So I can plug that here, arrow cos theta. So you can see that at any given point in time, if you have a right angle triangle, the side opposite the angle is the hypotenuse sin the angle. The side adjacent to the angle is the hypotenuse cos the angle. I repeat, hypotenuse sin the angle and hypotenuse cos the angle. Now, let's use that to bring in all the values for this side here, taking note that we are assuming that the units or the distance here is a unit of 1. Now, this is the hypotenuse, this is the opposite. Remember, we said hypotenuse sin the angle, that is 1 sin B. So I can simply plug in sin B here. Then this side will be the hypotenuse cos the angle. So I can simply plug in 1 cos B. So this is simply what? Cos B. Now, over to this side, you have the hypotenuse sin the angle. Now, the hypotenuse here is cos B. So you have cos B sin the angle. Now, the angle here is A. And for this side, hypotenuse cos the angle. So the hypotenuse is cos B, and the angle here is simply cos A. Now, we've generated this, and this. So we still need to generate more things before we can now get our formula for sin A plus B and also for cos A cos B. Now, you move with me. So I'm going to draw a straight line from here down to this particular point. So this is what you have. Now, we are assuming, remember, this is not just drawn to scale. We're assuming that here is 90 degrees. Then we're also going to draw a straight line from here down to this point. Also, here is 90 degrees. Now, we are going to generate some distances here. So with that distance, we can now get the answer for sin A plus B and also for cos A cos B. Now, if you take a look at this, the distance from here to here is parallel, this line here is parallel to this line. So therefore, this particular line here, we can call it a transversal. So if from here, if this and this, they are parallel and this is a transversal, remember, you are told that if you have something like this, another line parallel, and you have a transversal, this angle here and this angle here, they are equal. And we can call them what? Alternate angles. So the same thing is going to happen here. Also, this angle here and this angle here, they are equal, the same name, alternate angle. So if here is angle A, it means that this angle here is also going to be equal to what? angle A. Now remember, we agreed that the full angle here is 90 degrees. So if the full angle here is 90 degrees, so the angle here should be 90 minus A. So I can say that the angle here, so let me use this symbol. The angle here from here is simply equal to 90 minus A. Reason being that from here to here is 90 degrees. We've agreed that here is A, so here has to be 90 minus A. Now that we've gotten that, we can now find this smaller angle here. Remember, everything here is simply what? A right angle triangle. So I'm talking about this triangle from here down to this point, back to this place. So here is a what? Right angle triangle. So what will this angle be? So if I call this angle X, it simply means that X plus 90 minus A plus this 90 degrees should be equal to 180, because the sum of angles in a triangle is 180 degrees. So your 90 plus 90 is 180. So S minus A plus 180 is equal to 180. So 180 cancel 180. If I move 180 to the other side, so I can say S is equal to A. So therefore, this angle here is also equal to A. Now we've gotten this angle to be equal to A. I think there's one more distance that we need. There are some more distance that we need to know. Now, if this angle is equal to A, I can now decide what this side is and also decide what this side is. I repeat, if this angle is equal to A, I can decide what this length is and also what this length is. Remember, we agreed that everything from here is the hypotenuse sine the angle, because it's opposite the angle, while everything here is the hypotenuse cos the angle, because it is adjacent to the angle. So this is opposite the angle. So since this is opposite the angle, I can call this distance here. So let me move it like this down to this place. This distance from here to here is equal to, the hypotenuse here is sin B. So you have sin B, sin the angle. So the angle here is sin A. And similarly, this distance here is sin B cos the angle, and the angle here is what? Cos A. Now, my sin B cos A is a distance from here to this part, while my sin B sin A is a distance from here down to this particular part. Now, I can generate my formula for sin A plus B and also for cos A cos B. Now, if you look at what you have on the board, if from here to here is A and from here to here is B, it means that this full angle here is A plus B. I repeat, if from here to here is A and from here to here is B, it means that this full angle here is A plus B. Now, if this full angle here is A plus B, what is this distance from here to here? Now, you can see that if here is 1, the hypotenuse, the opposite, like we said, is the hypotenuse, which is 1, multiplied by the sine of the angle here. And the sine of the angle here is simply what? Sin A plus B. This hypotenuse here is 1. The hypotenuse, sorry, this opposite side here is this hypotenuse 1 multiplied by sine the angle here, which is A plus B. So therefore, I can say this full distance from here down to this particular point is sin A plus B. So if from here down to this particular point is sin A plus B, what is the distance from here to here? So let me write that here. So my final answer for sin A plus B is equal to, from here to here, we call it sin B cos A. From here to here, we call this sin B cos A. Then what else do we need? From here to here, we call it cos B sin A. So you can see that from here to here plus from here to here is simply the full length here. So sin B cos A plus cos B sin A. So let's make the sin A come first. So my final answer here should be sin A cos B plus, here you have what? Sin B cos A. So that is the value for sin A plus B. Now over to cos A cos B. Now for cos A cos B, remember we agreed that everything here, okay, so let me just put it here. So everything here is A plus B. So therefore, this distance here is hypotenuse sin A plus B, while this distance here will be the hypotenuse cos A plus B. So from here, down to this particular point, I should be having a value of cos A plus B. Now, what is this distance from here to here? So we can check. Remember, we agreed that from here down to this particular point is cos A cos B, and from here down to this particular point is sin A sin B. So therefore, from here to here should be from this particular length to the ending minus from this particular point to the ending. So I'll be getting my cos A plus B. So if I should write that here, my second answer is simply cos A plus B is equal to everything here, which is cos A cos B, minus from here to here, which is the same thing as from here to here, that is sin A sin B. Like we all know, this is the answer you get when you solve this mathematics. Then, however, like I said, after getting for A plus B, we are going to use this formula to generate for A minus B. So my sin A minus B, so if I put a minus sign below, my sin A minus B should be sin A cos B minus sin B cos A. As simple as that. And similarly, my cos A minus B, so if I put a minus sign here, should be cos A cos B plus sin A sin B. So these are the formulas for compound angles involving sine and cos. In our next video, we'll be looking at tan A plus B and tan A minus B. Now, if there's any part of this solution that you don't understand, you can leave it in the comment section. Then if you have any other thing you want to add to what we've done, you want to shed more light on what we've done, you can also leave that in the comment section. Thanks for watching. If you are yet to subscribe, please subscribe to this video. Feel free to like this video and also share to your friends. See you in my next video.